Step 5. Perform sensitivity analysis. A follow-up sensitivity analysis is virtually a must in any real-world decision analysis, and PrecisionTree makes this easy to perform. The usual goal is to vary one or two inputs and see how or whether the optimal strategy changes. To do this, it is easiest to have an input section in the worksheet where key inputs are stored, and then cell reference these inputs in the tree. The point is that you want to make sure that the tree changes automatically if the inputs change. Actually, it is also possible to perform sensitivity analysis on a number entered directly in the tree. However, this won't work properly if the same number, such as the probability of competing bids, is entered on multiple branches of the tree. To perform a sensitivity analysis, click the Sensitivity Analysis button on the PrecisionTree ribbon. This brings up the dialog box you see with many options. For now, you can focus only on the most important options. Later, you can experiment with other options. First, at the top, choose one-way or two-way sensitivity. With one-way, a single input is varied at a time. With two-way, two inputs are varied simultaneously. Second, choose the part of the tree you want the sensitivity analysis on. To make this analysis interesting in the current model, I will select cell D32 from the starting node drop-down list. This cell. This implies that the company has decided to bid, and we want to know how sensitive the optimal bid amount is to the input being varied. Third, click the Add button as often as you like to add an input to vary. You first choose the input cell, and then you choose the range over which this input varies. One input has already been added here, but I will add two others. Cost of completing the project varied from 25% below to 25% above the current value. And the probability of any competing bids. Here I will vary it from 0.6 to 0.95 in 8 steps. 60, 65, 70, 75, and so on. Note that only the checked inputs take part in the sensitivity analysis, so I will check only the cost of completing the project for now. Finally, choose the results you want. A good choice in this case is Strategy Region. And click OK. This is the Strategy Region chart. It shows a graph of the expected net gain for each of the three possible bid amounts, as the cost of completing the project varies over its range. Because the company wants the largest of these expected values, it will choose $160,000 when the cost of completing the project is low, $170,000, red, when the cost is in the middle, and $180,000, green, when the cost is high. If you check multiple inputs for a one-way sensitivity analysis, you can not only see a strategy region for each separately, but you can also check the tornado graph and spider graph options to see the relative influences of the inputs on the expected value from the chosen start node. I will check all three and check tornado graph and spider graph. Each of these ladder graphs shows how the expected value changes as each input varies over its range, while the other inputs stay fixed. Clearly, the expected value is most sensitive to the cost of completing the project. If you want to do a two-way sensitivity analysis, you must add at least two inputs. One must be X and one must be Y. Here I will create the strategy region for a sensitivity analysis on the cost of completing the project on the X-axis and the probability of at least one competing bid on the y-axis. The colors and shapes of the points indicate which bid amount is optimal for each combination of the two inputs: cost of completing the project and the probability of competing bids. Now it's your turn. Stop this video and perform the sensitivity analyses just illustrated. Make sure you understand what the results mean. Then perform one or more other sensitivity analyses.